In this video, we're going to talk about another way for multiplying two matrices, which is called the row-column rule. So this is going to be usually quicker than using the definition of the product that we talked about in the last video. Okay, so first I want to introduce some notation. So when I write A times B, when I write any matrix, and then I put this I and J in the subscript, what I'm talking about is the entry in this matrix that is in row I and column J. That's what this means. Okay, so let me visually show you guys what this entry is going to be. Okay, so I'm going to draw my matrix A. So draw matrix A. And I'm going to look at the ith row. So the ith row of A. So the ith row of A has terms like, I'll call the first one A sub I1. So I put I first to represent the row, and then the one after represents the column. So this is the first column. And then I'll have AI2, because now it's the second column, dot, 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 up until A sub I n. So my matrix is n columns. Okay, and now let's multiply this by some matrix B. And B might have different size, so I'm deliberately trying to draw it a little bit taller than A is. It might have a different size. Okay, but we've seen that for the product of two matrices to be defined, the number of columns in the first matrix has to match up with the number of rows in the second. So let's say that this also has n rows. And I'm going to look at the jth column. And let's label the entries in the jth column. So let's say that the first one is B1J. The 1 is first because this is row 1. J is second because this is column number J. Below that we'd have B sub 2J. 2 because this is now in row 2. And if I keep going down like that, I would finally end up at B sub NJ. Because this would be row number n, the last row. Okay, so it turns out the shortcut for figuring out what this entry is I begin by taking the first entry in row number I in the first matrix, and then the first entry in column J of the second matrix, and I multiply them together. So I would get A sub I1 times B sub 1J. And then I take the second entry of the first matrix, in the ith row, and then the second entry of column J in the second matrix, and I multiply them together. So I'll get AI2 times B sub 2J, and I add it to what I had first. And I keep going down like that until finally I get to the last one. So A sub IN, and then B sub NJ. So I'll get plus dot 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 plus, until finally I multiply those two terms. So I'd get A sub IN times B sub NJ. Okay, so at first glance, it may not be clear why this formula is going to be quicker than what we had in the last video. So let's do an example to illustrate how this works. Okay, so here is the example. So let's compute this product, so using this row-column rule. So this is actually the same example that we did in the last video. Let's just check what this looks like using this new rule that we have. Okay, so the row-column rule says that, well, we'll get a matrix. And what I do first is, so I'm going to begin by looking at this first row of my first matrix, and the first column of the second matrix, and I'll multiply all of their entries together term by term. So what I mean by that is I'm going to multiply this one times that one, the 2 times the 0, and the 3 times the 1. So that'll give me 1 times 1 plus 2 times 0 plus 3 times 1. Okay, so now let me go ahead and erase those lines. So when I multiplied the first row of the first A times the first column of B, that gives me the entry in row 1, column 1. So that's what I've filled out here, sort of the first entry of this matrix. Well, now let's look at the second row of my first matrix times the first column. Okay, so now I'll do the 4 times the 1, and the 5 times the 0, and the 6 times the 1. Okay, so those will go in the second row, first column of my product matrix. So that's here. So I'll have 4 times the 1 plus 5 times the 0 plus 6 times the 1. Okay, so awesome. So let me erase those blue lines so I can do that for the next one. So at this point, I've sort of multiplied each of the rows with the first column of the second matrix. Let's just call it, just so I can refer to it a little bit more simply, let's just call this B, and let's call this A. So we've multiplied the first 2 rows of A times the first column of B. But I still have to multiply the rows of A times the second column of B. So let's do that. First, let's multiply the 1 times the negative 1, 2 times the 2, and 3 times the 1. And that'll give me 1 times negative 1 plus 2 times 2 plus 3 times 1. So notice that when I multiply row 1 of A times column 2 of B, I'm writing that in the first row and the second column. Okay. And then finally, I have to do it for the last entry. Okay, so for the last entry, I would do the second row of A times the second column of B. So I'd get 4 times the negative 1, 5 times the 2, 6 times the 1. So I'll get 4 times negative 1 plus 5 times 2 plus 6 times 1. And if I work out what each of these numbers are, I get 4, 10, 6, 12. So if we compare this with the answer that we got in the last video, doing this same product, but using the definition of matrix multiplication, it's the same. So I deliberately did this example kind of slowly to show you guys how each of these products is sort of created. But as you get more and more practice with this, you can start doing computations like this and just go ahead and write what the answer is. So like go ahead and just write 4 instead of writing out all of these products. So it ends up being pretty quick doing it this way. So one other thing that I want to do as a reality check, which I did in the last video, but I haven't done here, technically I should have done this at the start, is to look at the size of all my matrices and make sure they sort of correspond and will be well defined. So A has 2 rows, 3 columns. B has 3 rows and 2 columns. So I know this is going to be defined because the number of columns of A and rows of B are the same. And I think of those middle numbers as sort of, canceling. So when I do this product, I'm left with a 2 and a 2. Okay, so my product matrix ended up being 2 by 2. All right, so let's look at one more example here. So let's do this product. So I have the same matrix A, but a different matrix B. So let's begin by looking at the sizes. So A is 2 by 3, but B this time is 2 by 2. And here I see that the 2 middle numbers are not the same. Like this is a 3, and then that's a 2. So as a result, this is going to be undefined. So one of the reasons why, beyond just seeing like, oh, those numbers are different, that's undefined, one of the reasons why it's actually undefined is when I start to do this row column rule, for example, with like the first row of A and the first column of B, I would do 1 times the 1, 2 times the 0, but now I have nothing to multiply the 3 by. So because of that, I get stuck, and that's why it's undefined. Okay, so I want to end this video by stating a definition that you guys will see in this section as you do the homeworks. So it's how we define the powers of a matrix. So, and I think it's pretty intuitive. A squared, for example, is just A times itself. If I have A to a K and K is some positive integer, then A to the K just means multiply A by itself K times. Okay, so in the next video, we are going to talk about some properties of matrix operations.